automata is derived from a Greek word that means self-acting. The motion of mechanical figure or automaton is generated by an input, such as a falling mass, a motor, or your hand. The automata motion is sustained through mechanical systems such as cams, gears, and handles. The design and building of automata combines critical thinking skills, engineering, and art. This video shows examples of automata that were displayed at the American Visionary Art Museum in Baltimore, Maryland. The automata are part of an exhibit from Cabaret Mechanical Theatre in London, a collection of whimsical, interactive automata. These examples include contributions by 3 automata artists, Paul Spooner, Peter Markey, and Keith Newstead. The works are listed only as mixed media. Most of the automata are constructed of wood, metal, or both. These automata were designed to be hand-operated. But for the museum exhibit, each machine was also automated, so an observer could push a button switch that runs a motor under the display surface that powers the automata. The first automaton example is the Last Dodo, created in 1986 by artist Paul Spooner. At the right end of the axle, you can see a chain wrapped around a gear feeding up through the display surface. As the unseen motor drives the chain, the gear turns the axle, rotating the cams attached to the dodos. The Last Dodo uses 3 different cams mounted on the single axle. Each cam controls the motion of a different dodo. The 2 cams that control the larger dodos are called pair cams. Notice that the cams have different orientations, 180 degrees from each other, which results in the dodos moving to different positions at different times. The smaller bird moves much more rapidly and is controlled by a different cam. This cam causes sharp movements, whereas a pair cam produces smooth motion. Now, pause the video and answer the following questions. Can you sketch the profile for this cam? How many times does the small bird move up and down during one revolution of the axle? How does the number relate to the cam profile? The next example is the Trojan horse, designed and built by the same artist, Paul Spooner, in 1986. This device is belt-driven. An unseen motor drives a rubber belt below the surface, which rotates the axle. Take a close look at this automaton before it's put into motion. How many cams are used to create the motion? Notice the orientation of the cams at varying rotational angles, each in a position to cause maximum displacement at a different time. Can you describe the soldier's vertical motion once the automaton is actuated? Pause the video to discuss these questions. Notice, too, that the followers are not vertically centered over the cams. Each follower rod is connected rigidly to a soldier, but the follower rod does not align vertically with its partner cam. Instead, it's offset. Think about what motion this misalignment will cause in the follower and soldier as the cams rotate. Did you correctly predict the soldier's motion? Each soldier moves up and down because of the pear shape of the cam, but each follower, and therefore the attached soldier, also spins about its center axis because the cam makes the offset follower spin. The next automaton we'll look at is the Muscle Man, which was constructed by Peter Markey in 1992. Before we show this automaton in motion, take a close look at the mechanism and predict the motion that will result when the axle is turned. Notice that there are 2 identical elliptical cams, but only 1 follower. Pause the video and answer the following questions. What will the resulting motion look like? And what function does the dowel that protrudes from the front of the follower disc perform? As you watch the motion of the automaton, think about which parts of the figure are attached to the follower. Is the head attached to the follower in the same way that the muscles in birds are attached? We refer to this connection between the head and the follower rod as a rigid connection. In other words, the head and the follower move as though they're a solid piece. Together, the head and the follower move up and down, and they twist. We refer to the linear up and down motion as translation, and the twisting motion as rotation. We can say that as a rigid piece, the head and follower have 2 degrees of freedom. That is, they translate vertically and they rotate about the vertical axis. In contrast, the arm muscles in birds only translate with the follower. They don't rotate. Rather, the muscles have only 1 degree of freedom, vertical translation. Continue to think about the variety of ways automation is part of mechanisms and systems in the world today. Then use these examples as inspiration as you design, build, and test a mechanical system to automate the motion of objects.